Okay, here's the answer. I'll see if I can put this into a different marker so I can help point out some things. So let's look at glucose for a start. This is carbon number 1 here. The reason being that, remember that that's that proton there that's going to come off, and that's going to go back onto this, and then that bond is going to shear, and it's going to come back down and join onto carbon, the carbon's double bond O there. You can't sever this carbon here, because if you did, you'd end up with a double bonded O on carbon number 5, and that won't make a aldehyde. It's going to make a ketone, because you've got this carbon up here and you've got another one there. So it's only possible to sever it from this bond here to make an aldehyde. Consequently, because, you know, the aldehyde is the terminal group in carbon number 1, I've labelled this one as carbon number 1, this is 2, this is 3, this is 4, this is 5, and the one hanging up the side here is carbon number 6. If we look at fructose over here, carbon 1 through 6, from the carbon closest to the double bonded O, being the one that's carbon number 1, you had two choices here. You could either sever the bond there, or you could sever the bond there. So how do we decide which one it is? Well, you look at this and you go, carbon number 5's got a hydroxyl group there, and then you look at the group down here on if we treated this as carbon number 5, well, where's the hydroxyl group? There isn't one. There certainly is one here. So consequently, I through deduction, I decided that was carbon 5. Therefore, this must be carbon number 2. Now, remembering that it's a polyhydroxyl ketone, so the double bond O ends up in the middle of the chain, so that's why this one's carbon number 1. And you start reading by going from carbon number 1, then up to 2, and then you come down to 3, and then you start going around the chain 4, 5, and then you move up to carbon 6. So that's how you go between glucose and fructose in their straight chain and ring forms. I've got to make a point here though. Yes, your Tollens reagent's going to react with glucose and not with fructose for the standard reason. One's an aldehyde, the other's a ketone. They need to be in their straight chain form in order to react. It can't react in a glucose form, because that bond O bond, that is not in its ring form an aldehyde. That oxygen is tied up. So in order to oxidize the carbon it's attached to, it needs to be a aldehyde group which is accessible to the Tollens reagent. And in order to do that, you must have it in this straight chain form here. Otherwise, it's not going to be able to react.